Back in the 1920s, a simple theory called the Big Bang proposed that the cosmos, which is currently expanding and cooling, was once hotter and denser. Since it has made a number of precise predictions that no other theory can match, it is frequently regarded as the explanation explaining the formation of our universe. However, the Big Bang is considerably more than that and is no longer the simultaneous origin of everything. If you ask a scientist how the universe came to be, they'll most likely say the Big Bang. Stars, galaxies, and the cosmic web of large-scale structure that connects them in our universe have not always been separated by such a vast void of nothingness. Instead, from a hot, homogeneous, dense, matter and radiation-filled state in which there were no galaxies, stars, or even atoms, the universe developed into its current configuration through expansion and cooling. Nothing was the way it is now in its current form 13.8 billion years ago. In addition, everything of that history has only recently been properly comprehended. Even so, many professionals and the majority of individuals don't fully comprehend a lot of its truths. Einstein outright rejected the idea when it was initially raised as a possibility. Newton's theory of gravity was proposed to be superseded by Einstein's general theory of relativity in 1915. It anticipated the presence of gravitational waves, which was only recently demonstrated, and predicted the mass bending of starlight, which was demonstrated in 1919. Newton's hypothesis was unable to accurately anticipate Mercury's orbital motion. However, it also implied that an unstable world would be one that was static or consistent across time and rich in matter. The theory that the space-time fabric of the universe may be very huge and expanding, having developed from a smaller, denser, more uniform state in the past, was put forth in 1927 by Belgian priest and physicist Georges Lemaitre. "Your computations are correct, but your physics is horrible," said Einstein in response. After Hubble established that the cosmos is expanding, it was given considerable consideration. Many scientists thought spiral nebulae in the sky were distant galaxies on their own before Einstein, but Edwin Hubble's research in the 1920s shown that this was not only true but also that the speed of a galaxy's separation from us increased with distance. In accordance with the Big Bang theory, Hubble's law, which governs the expansion of the universe, leads to a rather straightforward explanation. If the universe is expanding now, it was once smaller and denser. The idea has been around since 1922, but for many years it was largely ignored. After Einstein opposed to it, the theory for it was established by Soviet scientist Alexander Friedman in 1922. The idea that the universe used to be smaller, denser, and more uniform was still viewed as a far-fetched proposal despite Hubble's findings in 1929, which Einstein also dismissed. Hubble's findings provided the strongest support for the expanding universe theory, but he did not publicly support it until much later. Lemaitre made a significant contribution when he proposed that this expansion of space might explain the redshift of galaxies and that there must have been a moment of creation at the beginning, which was for many years referred to as either the primal atom or the cosmic egg. The idea gained significant momentum in the 1940s after making a startling string of predictions. George Gamow, an American physicist, was inspired by Lemaitre's theories. He realized that if the universe were expanding at the time, its wavelength would lengthen over time, indicating that the universe was cooling. If the weather is cooling today, it must have been hotter in the past. Extrapolating backward, he understood that there had been a period of time when the temperature was too high for neutral atoms to form, and that there had been a period before that when the temperature was too high for even atomic nuclei to form. The appearance of a primeval fireball, or a cosmic background of cold radiation just a few degrees above absolute zero, suggests that the light elements must have been created first, and then neutral atoms, as the universe expanded and cooled. Fred Hoyle, the most outspoken opponent of the theory, is also the one who gave it the nickname Big Bang. Nuclear physics supported the notion that the vast majority of atoms originated from dying stars rather than from this early, hot, dense state, and this theory became the dominant theory of the universe in the 1940s, 1950s, and into the 1960s. The steady-state theory of the universe, however, makes different predictions. Hoyle introduced the expression in a 1949 radio interview with the BBC by saying, "One of these theories was that the universe was created in a single, violent explosion a finite length of time ago, and that the current expansion is a byproduct of the power of that explosion." The Big Bang idea sounded flawed to me even before further investigation showed that it has severe flaws. When the Big Bang was first found in 1964, it was once thought that the light emanated from bird droppings. In 1964, while working on the Holmdel-Horn antenna at Bell Labs, scientists Arno Penzias and Bob Wilson discovered a constant radio signal that appeared to be coming from every position in the sky at the same time. Not realizing that this noise was actually the glow left behind from the Big Bang, they tried to calibrate it away. When it didn't work, they scaled the antenna and discovered pigeon nests inside. The signal continued even after they removed the pigeons' nests and excrement from that location. When it was discovered that the result was in fact Gamoff's prediction, the Big Bang theory was established as the scientific theory explaining the origin of the universe. Additionally, it makes Penzias and Wilson the only Nobel laureates whose work on cleaning up animal feces was recognized for merit. The confirmation of the Big Bang gives us a precise time frame for the origin of the rocky planets, galaxies, and stars in the universe. If the universe had been hot, dense, uniformly expanding at first, it would have taken a long time for gravitation to gather everything together into gravitationally collapsed structures. The universe would also cool and eventually give rise to neutral atoms and atomic nuclei. It would take between 50 and 100 million years for the first stars to form, between 150 and 250 million years for the first galaxies to form, perhaps billions of years for Milky Way-sized galaxies, and after many generations of stars had lived, used up all of their fuel, and perished in catastrophic supernova explosions before the formation of the first rocky planets. It's plausible that the universe took this long, or almost so, to ripen sufficiently for conscious life to exist, which is why we are still observing it 13.8 billion years after the Big Bang. By comparing it to how it was before the Big Bang, we may estimate how consistently fluctuating the cosmic microwave background is. Even though the cosmic microwave background is only 2.725 K right now, the oscillations shown here are only about 100 microkelvin in magnitude. The fluctuations are the source of all the structure, including the stars, galaxies, and other objects we see in the universe today. This is shown by the observation that there were minor non-uniformities of a particular magnitude in the early Big Bang residual glow. In essence, the Big Bang no longer represents the start of time. By extrapolating this hot, dense expanding situation, as Lemaitre did about a century ago, it is tempting to go as far back as a singularity. However, a number of discoveries, including modifications to the primordial fireball, tell us that there was once a time when space itself contained the entire universe's energy and that space expanded exponentially. The specifics of the cosmic inflation that took place during this time are still under investigation. There doesn't seem to be a stop in sight as science advances ever further. Furthermore, the way the universe began does not guarantee the way it will end. Last but not least, the Big Bang teaches us that the initial expansion, which wanted to rip everything apart, and gravity, which sought to recollapse the expanding universe, were in competition with one another. We cannot, however, predict the future from the Big Bang alone without knowing the makeup of the entire universe. Due to the discovery of dark energy in 1998, we now know that the most distant galaxies will continue to accelerate as they move away from us. But if the world had been generated with a little bit more matter or radiation than it possesses now, our fate in a dark energy cosmos might not be as cold, lonely, and empty. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.